Alright, so welcome back everyone. So last class, well, if you remember, we just talked about loops. So, while we've talked about iteration, we've talked about selection. Now, probably one of the next key fundamentals you need to know is modules. So modules, basically that's going to be a group of, let's say a group of reusable code that you can call kind of over and over again. Right, so basically there's two types of modules. One is going to be a procedure. Now a procedure will be a group of code that won't return a value. So basically it won't have an answer. Okay, maybe it can output, maybe it can do some processing, but it won't actually return a result. Now in contrast, a function, well likewise this will be a group of reusable code. However, this will return a result. So if we look maybe squaring a number, maybe repeating a string, calculating Pythagoras, just things like this. So in this class, well basically we'll just look at how to do all of these different activities. I would say most of these, these could be anywhere from sort of easy, I guess some medium, and probably some sort of more difficult exam style questions. Alright, so let's just jump in. And then I will mention actually, so two common functions you will need to know will be linear search and, well, bubble sort. Now I guess technically bubble sort is actually a procedure, in most cases. However, we won't actually look at these today because, well, these will be a separate video, right? Also, they'll require that we understand arrays. And we will look at arrays just quickly because, well, we'll talk about by reference. However, there will be a later sort of dedicated video to arrays and also linear search and bubble sort. So if we just look at the first one, so in order to actually declare a procedure, and let me just make the font a little bigger. Alright, we literally just use the keyword procedure, and here let's just call it a multiplication table. So here then we have the identifier. I guess we could use the underscore like this. Personally, I'm just going to use kind of like a lowercase for the first name, or lowercase for the first word, and then uppercase for the kind of second, and so on. So right, let's say here then we want the parameters. So the parameters, this is going to be the kind of input data into the procedure. And what we can do is we can call the same procedure but using different parameters, and then we'll get kind of different output, or different basically a different result. Alright, so if we think here, so we want to create a multiplication times table. So so not like a grid, okay, because that's going to be a bit too difficult for this class. But let's say we just want something like maybe 1 times 5 equals 5, right? Then it'll go 2 times 5 equals 10. Okay, and it will just print out the 5 times tables. So I think here, let's say maybe like times table. So this can be the first parameter, and let's say this is going to be an integer. And now let's also have the number of times we want to kind of loop. Right, so let's say here if we want to go up until 500 or something. So this one we can just call number of times. That's probably not the best one. But basically that's going to be this value here. Like if we go to 10, well, this will then go up until 10 times 5. Alright, and note how if the data types are the same, then we can go times table, right, then comma, then we have the next parameter, and then we say, well, the colon and then the data type. Now if, for example, let's say we also had some string, like maybe name, right, then of course, well, we need a comma, and then we declare, the second data type like this, right, or well, the parameter and then its data type. However, in this example, well, we only have integers. Now, just like we saw yesterday with while and then end while, also, well, I guess repeat until, also sort of for, and next. Procedure, well, we have kind of starting the procedure, and then we also need to end procedure. And if you see here, well, end case, end class, end function, right, end if. So I'm just going to end it, just so I don't forget. although the website will, well, the website should give you an error, okay, if you do forget. Right, so here then, I mean, we just want to think like how we can do this. So really, I mean, this looks like a problem that we can use a for loop, because we know, well, let's say we start at 1, all right, and then we're just going to end at, let's say here. And I'm actually going to change this. I'm going to say maybe starting position, and let's actually call this ending position. So, right, we'll have 2 parameters. So, yeah, which position we start at, and then which position we end at. So for example here then we can just have a for loop. Let's say this is going to be n, and we're going to start, and well, this will start at the start position. Okay, and then then we want to go until the end position. And I'm not sure why that's not giving me the code suggestions. All right, let me just change this to hopefully kind of refresh it. Okay, yeah, there we go. So now it's given me the code suggestions. All right, and then likewise, I'm just going to go next n. So this will just be, well, n plus 1 basically. Now here we just need to output. So let's go output. And then if you remember, well, first we want the actual number. So that can be, yeah, I guess that can be this n. All right, because for example, let's say we want 1 multiplied by 5 equals 5. So yeah, this first one is just going to be n. Right, then again, we need to concatenate. So let's have the ampersand. Right, we'll then concatenate with the multiplication. So, I mean, this is just outputting the string. It's not doing the calculation. And then, right, then we're going to concatenate again. So this one, right, this is always going to be 5. So this one will be the times table. Right, again, well, then we also just need to concatenate the equals. And then here, right, well, here we're going to concatenate, but right, this should be the actual answer. So if we think, well, this is just n multiplied by times table. Now, we could put this in brackets if we want, although actually we shouldn't need to put this in brackets because, well, multiplication will have a higher precedence or a higher priority than the concatenation operator. Right, so let's go n multiplied by times table. Now, some people think that, okay, we can just go run, but right, if we run, well, you see nothing happens. And the reason for that is, well, we need to call this. So yeah, to call it, basically this just means use it. So here we just use the call keyword. Right, then we have the procedure name, so multiplication table. Right, now here we need to give the parameters. So the first one is the times table, so let's just say 5. Right, the next one, well, this is the start position. And actually here, I mean, this should give us the function signatures, right? This should give us the parameter hints. Yeah, I think maybe there's some bug with the website, so I'll also look into that because, well, yeah, I mean, it was working before. Alright, but I mean, here we can just look at it and see them ourselves. So let's say here the starting position we want to be 1, and let's say the ending position, well, let's go to 100. So this should, well, it should go from 1 multiplied by 5, right, up until 100 multiplied by 5. And if we just run this, and yeah, okay, so we see, yeah, this is successfully working. Now, you know, the good thing with making a procedure like this is, like I said, well, this will be reusable. So in fact, let's make it just go to 10 because I think otherwise there's too much on the screen. Right, I'm just going to output just some hyphens like this, just so we can separate both of them. Right, but I mean, let's use it again, and this time let's do, I don't know, maybe the like, yeah, maybe the 52 times table. All right, why not? And here, I mean, let's start. Okay, I mean, so here, right, let's start at 5. So this should start at 52 multiplied by 5. And then, I mean, here, let's go to like 14, or just some random values like this. And if we see here, yeah, so it starts at 5 multiplied by 52. And then, right, it goes up to 14 multiplied by 52. So, again, I mean, yeah, hopefully, right, make sure you understand this. And yeah, and obviously, again, you know, the key feature of this procedure is that, you know, we can call it again and just use different parameters. All right, and then of course it's going to update here. Now let's say, for example, we made a mistake. Now if we made a mistake, or if we want to change the functionality, all right, let's just run this. Of course, we look at this, well, we see it's not working, and then we only have to change it in one place. Now in contrast, let's say if we copied this, and we copy it here, and we're actually hard coding this. So for example, we say, well, this one would be 5, this one would be 52, right, this one will be this 1, I guess this one would be 10, this would be 5, this would be 14. Now if we're copying and pasting this many times, well, then when we notice there's a mistake, well, then we have to fix it here, we have to fix it here. And of course, if you've got a program that's doing something like 10 times, 20 times, 100 times, well, that's not going to be realistic to copy it hundreds of times. And of course, again, it makes fixing errors difficult. It makes updating things difficult, because you have to change it in every instance. And I guess it just makes the code really long as well, because you're just copying and pasting the same thing over and over. Alright, so let's just delete that, and then we can have a look at the next one. So here we just want to output a n by m rectangle. So for example, maybe a 3 by 4 rectangle. And I guess we can also give the character in order to kind of show this. So for example, let's say if we want a 3 by 4, well, let's say 3 is going to be the rows, okay, 4 is going to be the number of columns. So if we're using the asterisk, well, we're just going to have like this. Alright, so this would be what we would want to output. And then we want to make a procedure, well, that's going to take, I guess it's going to take the number of rows, the number of columns, and also the character that we want to output. So again, if you feel confident that you can do this, just pause the video, have a go, and see if your solution works. Alright, but again, I'm just going to jump in, so let's go procedure, maybe just say like draw rectangle. Alright, and then so here let's go rows, let's go columns. I think columns is spelled like this. Right, so these are going to be integers. Now the next one is going to be a character, so the actual symbol. Right, okay. And in fact, I might actually put this one first, to be honest. The parameter order doesn't matter, but as long as you're consistent with, where you declare it, so in the procedure header, and then, where you call it, right, the parameters have to be in the same order. So, as long as they're in the same order every time, then it's fine. Right, so here then, this is similar to if we have a 2D array. So, if you've already learned arrays, if you're familiar with them, right, then the rows, well, that would be kind of the first dimension of the array. Right, then the columns, that's going to be the second dimension of the array. So in order to loop through kind of, a grid or a 2D array, well, basically we would need a nested loop. So when I say nested, right, that means a loop inside a loop. Just like we can have nested if statements, which would be if statements inside if statements. So let's say here, let's go 4. And first let's try just to print out the row number and column number. So let's say R. This will start at 1, and then let's go to the rows. So if we've got 5 rows, well, this will just loop from 1 to 5. Right, then inside here, let's go 4C, and this is going to go to the columns. Right, and then let's say here, let's just output. So we'll just output the row and also the column number. Right, and then let's go next C, and here let's go next R. So the thing to note, right, if we look at this, well, first it's going to start at 1, all right, and then then once it started here at 1, right, then it's going to go to this for loop. So then it's actually going to loop through all the columns. So for example, if I just draw this again, right, basically it's going to start here at 1, 1, all right, because, well, row is going to be 1, and column is going to be 1. Right, well, then it's going to output 1, 1. right, then we see this, well, next C, okay, it's going to go back here, so it's going to loop in this inner loop. So right, then column is going to become 2, right, so then it's going to be column 2, then column is going to become 3, right, so yeah, column 3, right, of course, then it goes to 4, yeah, then it's here. Right, now we get to the end because, you know, we're at 4, and yeah, the column number was 4. So then what's going to happen? Well, you know, of course, it gets to the end of this for loop. Right, then it goes to sort of this line here. And yeah, then it's going to go next R. So in this case, well, R now becomes 2. And yeah, then it's going to start again. Right, so R is going to be 2 and C is going to be 1. So of course, then it's here. Right, then it goes 2, 2, 2, 3, 2, 4. And then of course, yeah, you know, 3, 1, 3, 2, right, etc. I mean, so let's just try this, and yeah, let's see if it's working. So again, remember, we need to call it. Let's say here the symbol, I mean, right, since it's a character, it should be inside the single quotes. The rows, let's say that can be 3, and let's go 4, all right, just to make it the same as this. And yeah, I'm just going to comment those out. And yeah, okay, so we can see kind of the coordinates, or basically the index, yeah, the index values. Now, some people, they would make the mistake of thinking, okay, they can just go symbol like this. However, the problem with this is, well, output, this will always output a new line every time. So if we just run this, yeah, I mean, you see, well, we do get 12, but of course they're all on new lines. Whereas, yeah, we want it to be a rectangle like this. So the way we can solve this is, I mean, yeah, so we can actually declare inside here. So if we just go declare line, and then this should be a string, okay, because basically this line will just contain, you know, one line. So it's going to be multiple characters. Then, I mean, here we, yeah, I mean, I guess we should just initialize it to an empty string, just like this. Now, what we actually want to do, so here we don't want to output, but basically we just want to concatenate this to the line. So if we just go like this, line, and then this is going to equal line and the symbol. So if we think, well, line starts as just empty, so then we've got empty and then the symbol, which is this. So I mean, basically, well, now, you know, now the line is just going to be 1 asterisk. Right, then when we go the next time, so yeah, sorry, just here, the next time, well, the line is then going to be 1 asterisk. So then we've got 1 asterisk concatenated with another asterisk. So of course then it's going to become 2 asterisks, right, then 3, then 4. So yeah, I mean, and well, then we've got to think where we want to output. So I mean, if we output here, well, let's just see what happens. And yeah, maybe you can try to guess what's going to happen. So you see, well, first we get, yeah, 1, 2, 3, 4 like this. However, you know, the problem is, well, this is outputting every single column. So we just want to put this line just outside here. So it will get here once it's looped through all of the columns, which in this case is going to be 4 columns, right? Then it's just going to output. And yeah, if we run that, of course, that's going to work. And again, you know, the good thing with this, well, we could use emojis, maybe let's just use the plus symbol or something. And let's try 10 by 20. And yeah, okay, so you see this works. So yeah, I mean, obviously, again, I mean, that's the good thing about, you know, procedures functions. We can have the same code, but if we're giving different parameters, then we get different results. So obviously, you know, it makes it quite flexible. Alright, so if we try the last one, so we want to output the letters between a start letter and an end letter. So for example, if we have, let's say A, so right, A is the start letter, and, you know, let's say Z, right, Z is going to be the end letter. Well, of course, in that case, we just want to output, you know, A, B, C, D, right, all the way to Z. But, you know, we could also have this, I don't know, maybe, like, let's say I until, yeah, I don't know, like, maybe just M or something. Right, and then here, you know, it's only going to output these letters. Now, we could also do something like this, where we have, yeah, maybe like the multiplication. Now, I'm honestly not sure, like, if this would be before I or after I, but okay, so it should also work like this. And, you know, we could also do emojis, right? We could do, yeah, obviously, you know, different languages, yeah, basically any character. So we just want to think how we can do that. And we should have it where it's going to work if, say, the first character is A, and then let's say we go to Z, right, or we also want it to work, if it is Z, and then we say the last character is A. So yeah, we want it to go kind of forwards, right, and then also backwards like this as well. So right, let's just clear that. And again, just pause the video if you think you can have a go. Right, try and do it. And of course, if you make mistakes, well, it's good practice to try and fix them. And yeah, if you still can't fix them, right, then just watch the video, see the solution. So here, in fact, actually, let's call it characters between, because it can be any character, right, not just letters. Okay, wait, characters between, not characters letters. So again, this is going to take a start character and an end character. So let's just call it start, end, and let's go, character. Again, I'm just going to say end procedure just so I don't forget. Now, first we have to think, well, again, the two situations going from like A to Z or Z to A. So we have to think, right, how we can do this. And yeah, we also think, well, how can we actually just print like A, B, C, D? So how do we actually determine, what the next character is? So yeah, I'll let people just have a little think about how we can do that. Right, so hopefully, you might have seen that, well, we can just use the ASCII code, because obviously a character, well, or sort of a string, a character doesn't really have a sort of numerical value. But if we convert it to the ASCII code, well then of course it does have a numerical value, and when we have a numerical value, well then we can do arithmetic, right? Then we can loop through, we can add 1, we can add 5, right, whatever. So right, let's say here, and yeah, we can also have a step variable. So let's go declare, and we'll go step amount, and let's go integer. Now what we'll do, and okay, let's also say maybe like start ASCII. Let's also say end ASCII. So right, first we'll just convert the actual start character into its ASCII value. So if you remember how we can do that, let's just go start ASCII, and we're going to assign this, and let me check, is it ASCII? Yeah, okay, so ASCII, this one takes the character, then yeah, returns the ASCII value. So here then, this is going to take start, likewise for end ASCII. Right here, let's just get the ASCII character of the, let's get the ASCII value of the end character. And I would say, before like trying to write the whole thing, then kind of, being confused why it doesn't work, just do small amounts, then test it, or do it a little bit more, test it. So let's say here, let's just go output start ASCII, and let's also then output end ASCII, just to test this is working. Again, let's call it, and here let's say the start character can be A, and let's say the end character can be Z. And yeah, okay, so we see 65 and 90. Now if we look, of course, again, if we go, let's say Z, or in fact, let's do small z, and actually let's go small z and then big A. So right here we see, well, 122 then 65. So if you notice the difference, that obviously in this case, well, we say the start position is going to be bigger than the end position. So this is where we can actually modify the step amount. So I think we should be able to do something like this. So if we go for, let's just say n, right, this is the current character, basically. Or yeah, okay, let's call it like current ASCII. And yeah, maybe I can also make it uppercase, because yeah, this is like an abbreviation. Yeah, I'm not sure, maybe the American Standard something. Yeah, I'll probably search later. Alright, so here then, this is going to start at the start ASCII. Right, and then we want to go to, right, and then let's go to the end ASCII, and then the step. So the step is going to be the step amount. Now, at the moment, we've not actually assigned anything to the step amount. So we have to think, right, if the start ASCII is smaller, so for example 65, and let's say the end ASCII is bigger, so 90, well then we want the step to be, 1, right, so just the default. So what we can do is, let's say, right, if, Yeah, I'm trying to think if there's kind of a quicker way we can do this. I guess let's just use an if statement, right, the simple way. Right, so if start ASCII is greater than end ASCII, and I mean let's also get greater than or equal to, because otherwise if we just have greater than, then if we have else less than, yeah, then you could get a situation where, well, if it's equal, right, then this step amount would just be undefined, or I guess it might be 0, right, it would just have the default value. Okay, yeah, let's use then. And then what we can say, so here then the step amount should just be 1. And I suppose, I mean pseudocode doesn't really have an else if, so let's just go else. And then we'll say step amount is just going to be -1. Alright, and then we'll just end, end if. So I think this should work. And actually, let me just comment this. And again, like I said, right, let's just test it. So here, I mean, well, let's just try maybe big A and then, let's say big Z. So this one, the step amount should be 1, right? Because we just want to go, A, B, C, D. So it's going to +1. Okay, so this is -1. So if, I mean, okay, it should be like this, right? So if start ASCII is smaller, alright, then, okay. Alright, so that works. And then let's try the other way. So let's say Z and A. Okay, that goes to -1. And then if we try Z and Z, well, Z and Z should be 1, right? Because we're checking less than or equal to. Okay. So I think this should work. So let's just uncomment this. And we can probably delete this, to be honest. It's just used for testing. Right, and again, you see, well, it was good that I tested, because obviously I also made this kind of silly mistake here. So don't try and write all the code in one go. Right, so then we want to go next, current ASCII, because, well, that's the identifier name in the for loop, or the count variable. And I mean, let's say here, maybe we just want to output the number and then the character. So I think that's fine. So right, let's go output. So the number will be the current ASCII, and then let's just go and then here we will just say maybe colon like this. Right, and then we want the current ASCII, but we want to convert that to the character. So in order to do that, we can use the chr function, and again this takes an integer. So for example 87, and then it just returns the character that is represented by that ASCII code, or by that Unicode. Right, so here then this is the current ASCII, and I think this should just work. So let's try A to Z. Okay, so 65, 66, right, down to 90. Now let's try Z to A. So let's try that. Okay, that's fine. For example, we can also try maybe big Z to small a. Now if people actually know this, so this one is going to be 90. This will actually be 122. So this is actually going to go forward. Even though people might think that, well, big Z is after small a, because the kind of uppercase letters are before the lowercase letters, in ASCII, then okay, so here there's actually not many. Now if we try, let's say, big A to small z, I mean that's going to be a lot more, right? Also including some of these punctuation characters. And I mean let's try and output like okay, I wanted to say from 0 until 255. However, we can't really do 0 because, well, 0 will be the null character. So I mean we could just have this in a loop. We could just output the characters in a loop. Now let me see if this works. So let's say chr. So let's say chr of 0. So this should get the null character. And then let's say chr of 255. I mean, hopefully. Okay. So we see, well, right, this one is the null character. And we see actually all of these, well, the first 32, right, they're going to be unprintable. Number 10, right, number 10 is the new line character. So if you're not familiar, well, the new line character is, well, \n. That's how we can write it. And, well, basically that, I mean, that's you can think of that as like the enter key on your keyboard. So if you press enter, right, it's going to make a new line like this. And yeah, I guess there's a few others. Yeah, and well, obviously we can see here, right, we've got some yeah, mathematical symbols, right, whatever. Yeah, I guess some currencies. Yeah, some currencies here. And yeah, some sort of different kind of accents and things. Now, you know, we can also go, let's say we want to go from, I don't know, maybe 127,000, and let's say until 128,000, or yeah, maybe 129,000. So I think a lot of these, they should be the emojis. Yeah, okay, so actually, I mean, here, these are kind of strange, to be honest. They're sort of like pictograms. But I mean, yeah, we see, right, okay, we've got some emojis there. Yeah, I guess somewhere there's going to be some more. Yeah, we've got some more emojis. But I mean, honestly, if you just want to output all the different characters, well, you know, you just go in a loop like this. So actually, let's just do that. So to output all of the characters, say from 0 until, you know, 128,000, you just go, right, for n equals 0 like this. Let's go to, I'm just going to say 1,000 because, well, otherwise it's going to take too long. Let's go next n. All right, and then here we just go output, and we want to output, yeah, again, you know, I always forget, CHR of n. And yeah, of course, right, that's going to output the first 1,000 like that. So I think one other thing I mentioned was the \n. So this is quite, you know, quite useful to know. So let's say if we have, you know, ABC, right, then if we go \n, you know, DEF, these will actually be written on a different line. Right, so yeah, we can see here, because we've got this new line character. Now, you know, if, for example, we do more new lines like this, yeah, then you can see, well, we just get extra new lines like this. All right, so I mean, that can be useful to remember. Yeah, rather than just having to do, for example, yeah, output ABC, then on the next line we go output DEF. You know, you'd need many different output statements. Alright, so I mean, I think for the procedures, I mean, yeah, that's all of them done. So if we saw, and you know, this is something that confuses probably a lot of people. Now, I mean, okay, they did output things in terms of, you know, they output it to the screen, but they didn't actually return a result. So, no, in fact, hang on, let me see. Right, so we've seen then that we can use a procedure in order to output a value. However, we couldn't use a procedure to assign to an array, for example, or, you know, we couldn't use a procedure like in an if statement, or at least, you know, in the condition of an if statement. For example, like, I don't know, maybe, for example, this check pin. So this will return a Boolean true or false. So, you know, here when we use this, we can go something like, right, if check pin, you know, then we call that, right, and this is going to have a, you know, pin number like this. We could do something like this, right? Because here, right, this function will return a value, either true or false. Yeah, whereas in contrast, a procedure won't return a value. So, you know, if we did something like, you know, I don't know, this multiplication table, well, you know, this is, yeah, this is just going to return nothing, alright? So, yeah, we wouldn't be able to use it like this. So yeah, I mean, let's just look then how we can actually make a function. So if we look at the first one, well, we just want a simple function that takes a parameter and then squares it. So of course, if we have like 4, well, it's then just going to square it like this, right? 4 squared. So again, the syntax is, you know, quite similar. At least, well, you know, half of it is similar. So let's say this can be called square. Again, right, then we have the parameters. So here, I mean, let's say this could be a real number, because they could say, you know, like 1.5 squared. And I think we can just call this n, that's fine. Let's say this is of the type real. Right, and then this is where it's a bit different. So here we have to say the data type that it's going to return. And in order to do that, we actually use this returns. Alright, so returns with an s. So here we're saying, well, this function will, well, this function returns, and then this is also going to be a real. Because, I mean, if this input is a real, then, you know, 1.5 squared, right, is also going to return a real. Or yeah, the answer is going to be a real. Again, right, let's just go end function, right, just so we don't forget. Now here then, this is where we're going to return. I mean, you know, sometimes we would also need other code here as well, but this one we can do just in one line, right? It's quite simple. So all we can do, well, we could do n times n like this. We could also just do, right, n to the power of 2. You know, it's going to be the same. So what this is going to do, well, it's going to calculate this, then it's just going to return the answer. So for example, let's just see here, let's go output, and yeah, let's go square, and let's say 4. So basically it's going to take this square of 4, you know, well, this 4 is going to be the parameter, which is going to be this n value here. Right, then we're doing, you know, n squared basically, or n to the power of 2. So right, it will calculate that this is 16. Then once it's calculated that this is 16, well, this 16 will, well, you know, like this square 4 will then become 16. Because, yeah, I mean, this is the value that's being returned from this function. So, like, if we just see this, well, basically this will just output 16. And yeah, okay. So I know some people, you know, get a bit confused about what's going on here, like if they're new to functions, but I mean, hopefully it should start to make sense. So you think, well, right, this parameter again, well, I guess, yeah, technically this is an argument here. So the actual kind of specific value is the argument. And then, yeah, this is going to be the parameter inside here. So, right, I mean, we're passing 4 in as a parameter into this function. Right, I mean, this n, well, yeah, this n is then used here. Right, we then raise it to the power of 2. So this would be, you know, 16 in this case. And then we just return 16. So return, well, that just means, you know, this is now going to become 16, right? Because, yeah, that's what we've calculated. And of course, you know, just like before, we can then change this. Well, we can just copy it. Let's try, you know, 2.5. And let's try maybe like 999, or yeah, maybe some more like this. And yeah, again, so we see this is working for all of them. I mean, let's also try maybe something like this. Yeah, I'm just curious what this is going to equal. Yeah, okay, so I mean, I think basically just kind of completely random. Yeah, I think like no pattern basically. Alright, so yeah, if we go on to the next one, and again, you know, just pause this if you want to have a go. You know, again, it's just going to be using the same kind of syntax. So right, I'm just going to delete it just so we can, you know, practice writing the whole thing again. So let's say function, let's call this, let's do maybe small like this. Let's go string repeat. And then, so what this is going to do is, let's say we have the string, I don't know, ABC. Right, and we say we want to repeat this 5 times. Well, you know, then this is going to go like ABC, 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 ABC. Right, so just 5 times. So yeah, the parameters, well, again, we're going to need the string, and then we also need the number of times to repeat. So I'm just going to call this S, maybe. This can just be the string. I mean, yeah, this can be N, or maybe, yeah, times to repeat. Yeah, I mean, well, let's call it original or something, right? Because I think Cambridge want you to be descriptive with the variable names. Right, so this times to repeat, well, this is going to be an integer. And then you have to think, well, what is the return type going to be? So again, we just need returns like this. And yeah, let me just make that wider. And then we think, well, here, you know, if this is going to return sort of like ABC, 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 then, right, this is also going to be a string. So yeah, let's just go return string. Again, let's close the function just so we don't forget. And yeah, then we just need to think, well, how we can do this. So, you know, if this is similar to kind of totaling. So if we have a number, or yeah, if we have like a list of numbers, say an array, yeah, or maybe just, you know, multiple variables, you know, we can set, say, a total as being equal to 0, right, and then just kind of add to the total. Well, likewise, we're doing the same here, where we can just set an initial string just as an empty string, and then we're just going to, you know, repeatedly concatenate to that string. So let's just go here. Maybe let's just go, I mean, maybe like result, basically. And this is also going to be a string. Okay, let's go result, and let's just assign this. Yeah, let's assign it just an empty string like this. And then what we can do is we're going to say for. So here, if we want to loop, say 5 times, well, again, we're going to have this n variable. Alright, and well, I mean, this can be called anything. You know, you could call it, okay, not that. You could call it count like this. But right, I'm just going to go n. And yeah, so this is going to go from 1, and then it's going to go to the times to repeat. Right, and let's go, okay, yeah, let's go next n like this. And what we want to do is, well, we just want to concatenate this original string, right, with this result. So let's go result, and yeah, this is going to be result, and then the original string. So if we, and then, well, let's make sure to return it at the end. So if we think how this is going to work, well, again, right, result starts as an empty string. Right, so then we've got, well, an empty string, and then so joined, yeah, with the original string. So the original string can be ABC. Right, so now, I mean, now this means result is going to be ABC like this. Again, right, on the next time. So this is similar, yeah, this is similar to the rectangle that we looked at before, you know, just with the different lines. Yeah, so when we go the next time, well then, right, this one will be ABC, right, from the previous time. Again, this is also ABC, right, so of course now it becomes, yeah, ABC, ABC. And then obviously the third time, well, this is now you know, 2 ABCs. And then this, well, this is just, you know, 1 ABC. Right, so it's going to become 3 like this. So yeah, let's just test this. So again, let's go output, let's go string repeat, and let's try this example. So ABC5, and actually I'm just going to give it a space, right, just so we can actually see, because yeah, otherwise it's a bit difficult to count. Right, unexpected token. Where is that? Okay, so 86. Okay, so yeah, that's just my example here. So let's just delete this. And yeah, okay, here we go. So now we've just got 5 ABCs. And again, of course, you know, we can do this with anything. And I mean, you know, if we really wanted to, we could go, yeah, I don't know, maybe A like this. And you know, I mean, this is kind of stupid. But I mean, we could have a function inside a function. Because, I mean, here, well, this is going to return a string. Right, so this is going to be 5 A's. And then let's just go, well, in fact, I mean, yeah, I don't know, let's just go like B or something. And then let's also have this another 5 times. So this is going to be 5 A's, then it's going to be a B, right, and then, well, then it's just going to do the whole thing 5 times. And let's also have this be a new line, so each one will go onto a new line as well. And yeah, you know, then we just get this. So I mean, I guess really we could have used this actually just to do our original, you know, this n by m rectangle. So for example, if we wanted, let's say this one, and yeah, and well, then we can just have the new line like this. And then I think what we had 3 by 4. So right, this is going to be the columns here, and then this will be the rows. So yeah, here if we have like 4 by 3, right, that's going to be 3 rows and then 4 columns. Yeah, okay. But again, you know, in this example, it's kind of crazy, right, having the string repeat inside the string repeat. Right, let's think how we can do Pythagoras then. So what this is going to be, well, we're going to have an A value and a B value. Then we just want to calculate C. Right, and this is according to, well, the, you know, Pythagorean theorem, that yeah, a squared plus b squared equals c squared. So again, right, pause the video, have a go at this, and to be honest, this one's actually a little bit easier. Yeah, so well, let's just have a go. Let's go function Pythagoras, and then here let's go right A and B. Now we want to think of the data type. Now because these are going to be lengths. Yeah, well, you know, because they're going to be lengths, right, they can actually be real, because it's not necessarily going to be a whole number. Now, likewise, you think, well, if we got, you know, real numbers, we're kind of squaring them, we're square rooting them, well, this can also return a real. In fact, yeah, like in most cases, it is going to be a real number. yeah, there's not many situations where Pythagoras returns a whole number. Right, so if we think then, let's just go return. So I'm going to put this in brackets. So first we just want to have a squared. So I mean, actually we could just go a times a like this. However, I'm actually going to use the exponentiation operator, because of course, you know, we could also do like, you know, sort of a to the power of 8, for example. Whereas, you know, to do something like this, yeah, like a times a times a times a times a, right, that's going to be difficult. And, you know, if we want to do to the power of, say, 1.5, or, yeah, if we want to square root, right, then, of course, we can't do that using the standard multiplication. Right, so, yeah, let's go to the power of 2. Then we just want to plus with b squared. Now, here we actually don't need brackets, because, again, well, you know, the exponentiation has higher precedence than the addition. However, I'm going to use brackets, you know, just because... Well, I think otherwise, you know, you'll make mistakes, and then, yeah, you'll realise, well, yeah, you'll kind of be stuck, like wondering why there's a mistake. Yeah, although, you know, this one is quite simple, hopefully, so, yeah, I think, you know, we shouldn't make a mistake. Right, and then, so here, let's say this one's going to be to the power, and then this one can just be 1 divided by 2, right, because I think, yeah, 1 divided by 2, this should be the square root. Yeah, or, of course, we can just do 0.5. But again, I'm going to do 1 divided by 2 because, well, if someone says, you know, they want the 7th root, well, the 7th root we can easily do like this. Whereas, you know, yeah, having to do like 1, you know, writing this as a decimal, well, it's not going to be very accurate. Alright, so yeah, let's just test this. So let's go output Pythagoras. And then I think one of the Pythagorean triplets, just 3, 4, 5, because, well, 3 squared is 9, right, 4 squared 16. So yeah, this is going to be 25, and then, okay, let's change this back. Yeah, 25, you know, square root, that should just be 5. And yeah, okay, so here we see. And now, for example, if we try, I don't know, let's try 5. And yeah, now we get this. So yeah, I think that's working. So right now then, if we try the next one, and yeah, I realise there's, you know, lots of examples in this video, lots of practice. So, well, here then we just want to create a function that's going to swap the case. So if we have an input string, let's say, I don't know, maybe hello, like this, then what that's going to do, well, that's going to be output as small h, and then, you know, big E, like this. So any uppercase letter will become lowercase, and yet any lowercase letter is going to become uppercase. Alright, so yeah, that's what we want to do. So again, right, pause the video, have a go, see if you can do it. But yeah, I'll just get started. So let's go function, we'll say swap case. Now we need to think the parameters. Well, here we only have one input, right, so one parameter. So here maybe let's say, I'm going to say str, so just the original string. Right, and then again we need to think, well, this will take a string, right, then it's also going to return a string. So let's say returns, this will be string. Let's go end function. Right, now here we need to, well, again, just, you know, have a think how we can do this. So yeah, we need to go through character by character. Now, if you remember how we can do that, well, we can use a for loop, and then we can also use the mid function in order to get the current character. Yeah, or, well, you know, I guess the mid function to get a kind of, yeah, substring of characters. Right, so yeah, I mean, yeah, I was thinking we could do this in place, which means we don't actually need another variable, although I am actually going to create another variable just because, well, I guess it's easier. So let's say result. Right, this is also going to be a string because, well, this will be the variable that we return at the end. And I mean, let's actually just do that now, right, just so we don't forget. So return result. And then inside here, this is where we're going to append to the result. So let's say for, let's say, I mean, just n, right, n is the current position. This is going to start at 1 because we start at character 1. Now, I mean, here, of course, we can say 5. But, you know, of course, if this was like hello 1, 2, 3, well, now it's going to be 8. So if you remember, well, we can use length. So yeah, this will get the length of the string. And this one is going to be the length of str, okay, because str is the parameter. Right, and then here let's go next n, right, just to close it. And then what we want to do, well, we need to check, like, is it an uppercase character or is it a lowercase character? So I mean, again, I'll just let you have a quick think, right? See if you can figure out how we can do that. Okay, so maybe you've realized that in order to do that, again, I mean, well, like we've seen so many times, right, we can just use the ASCII values. So I mean, this is why it's so important to remember, you know, let's just do it here. So, well, big A is going to be 65, right, and then let's say small a is going to be 97, and then 0 is going to be 48. And then of course you just remember, well, Z, right, Z is going to be plus 25, so Z is going to be 90 here, right, big Z is going to be 90, and small z is going to be 122. So right here then we just want to check if the ASCII value is in that range. So I'm just going to go declare here, so let's say maybe current ASCII, yeah, just to stop myself having to use the function over and over again. Right, and then this one is going to be, right, this one's going to be an integer. Right, and then what we'll do is we'll say the, I mean, okay, well, let's just test this first. So let's go output, you know, just so we can output the current character each time. Right, okay, so output, and this is going to be, right, so mid, then we want str, right, this is the input string. Right, then we want the position. So the position is going to be this n, right, because again, this will be 1, 2, 3. It's just looping through the string, you know, until the length of the string. And then, well, the number of characters we want is going to be 1, like this. I mean, well, this result is going to be empty, but I mean that's fine at the moment. Let's go output, and let's say swap case, and we'll just try hello. So this should just, well, it should just output, you know, H, E, L. Yeah, so just each of the characters like this. Okay, so this is working. And then what we can do, well, let's say current ASCII is going to be this, but again, this is the character, so we need to convert this into the number. So in order to do that, I think, yeah, ASCII, so this takes the character, right, returns the integer value, yeah, of the, you know, ASCII code or Unicode. Right, then we can just have if. Yeah, I mean, or we could use a case for this, right, that's also fine. So, I mean, well, let's try and do both. So if we go case, let's go case of current ASCII. And then, for example, we just say, well, 65 and then 290. And yeah, that, you know, then we just do, well, whatever we're going to do here. Now, I mean, all right, I'm just going to use an if statement. I mean, honestly, you know, a case is quite nice because, well, this syntax is quite nice, right, 65 to 90. But I think a lot of students actually find case, you know, maybe a bit harder to remember. And like, that's probably not because it's more difficult, but probably just because they use it, you know, less frequently. So, right, yeah, let's just go with an if statement. Let's say if current ASCII is greater than or equal to 65, then we're going to say and this should be current ASCII is less than or equal to 90. So if we say this, well, this means it's going to be an uppercase letter. So now you have to think, well, how do we convert from the uppercase H, right, into the lowercase h? Right, so if you remember that, well, we can just plus 32. So let's say here we want to go result, and then this is going to be result, because again, like, let's say, okay, so we've done the H, right, then we get to the E. Well, we need to remember the, you know, the previous result was the H, right, and then we're going to append the E. I mean, I'll show you what happens if we don't have this, you know, result and. But basically, it's only going to get the first letter because, you know, you would just be overwriting the result just with the most current character. Right. Anyway, so yeah, then we want to go right, CHR. So CHR, this takes the current ASCII and then just plus 32. Right. Then we can just go. Yeah, I mean, so we actually can't just go else, we actually need to have an if inside this. And, you know, this is why a case is actually quite nice, because we wouldn't need this nested if. And then so here we want to go is, yeah, okay, greater than or equal to 97, and current ASCII is less than or equal to 122. And yeah, here I've also forgot the then. Right, and then actually I'm just going to copy this, because all we have to do is just make it -32. Now this is the problem of having nested ifs, obviously it can get quite complex if you have like ifs inside ifs inside ifs. Yeah, but we just need to remember we need two end ifs, because yeah, I guess this if needs the end if, right, and then this if else, this then needs the end if. Yeah, and then I think that should work, so let's just have a go. Yeah, okay, and then this works. Now if for example we try like numbers as well, let's try make exclamation, something like this, right, so they should be left unchanged, which that's what we want. Okay, alright, so yeah, here I've actually made a mistake, so maybe you can see the mistake I've made. Alright, basically what we want is, here we want an else, because this is, if it's not an uppercase, yeah, okay, so, yeah, here, like if it's not an uppercase and if it's not a lowercase, right, then it's going to go to this else. And then here we can just say, this is going to be results. And then, basically it's just going to be this mid, right, this is the current character. But I guess, yeah, we can just take this, and then just, yeah, do this. So this will mean, just, don't change the character, basically. Yeah, if it's not an uppercase or if it's not a lowercase. And again, right, this was the problem I was mentioning, that if we forget to concatenate with the results, yeah. Alright, so, I mean, this one is a bit more complex, but, this is obviously just combining, everything we've done. So we've got functions, we've got variables, right, we've got loops, so iteration, yeah, we've got, say, selection, and again, right, this could be done either using the if, or it could be done using the case. Yeah, I mean, I might just do the case now just to compare it. So let's go case of, right, let's do this quickly. This will be current ASCII. Let's go end case. Let's say here, so 65 to 90. And then here it's going to be result. In fact, did I copy this? No. Okay, let's go result. That's going to be result. And then concatenated with CHR. Yeah, that's the current ASCII plus 32. Right, then let's just copy this, and yeah, let's also copy this. So this one will be 97 until 122, this is -32. Right, this one will just stay the original, and then if you remember, here we just go otherwise, so this means, if neither of the conditions match. And to be honest, here, you can see, right, the code is actually shorter, and yeah, I think in many ways it's more simple. So, it does just depend on, yeah, which you prefer. And yeah, you see we run that again, and we get, the same result. Let's say maybe like ABC. Yeah, okay, then you see it just switches them. Alright, so yeah, now let's say we want to try this pad, because we'll need this pad in order for the check pin, and then also brute force pin. So, alright, let's just delete all this. So basically what padding means is that if we have, let's say a number like 0, yeah, let's say we have a number like 0. Now if you think, say like on a pin machine, so a pin machine like like an ATM machine, now we can't just type in the number 0, right, it's going to have to be 4 digits. So basically the number 0 would actually be represented as 4 zeros like this. Likewise, say the number, I don't know, 15. 15 would be represented as, 0015, because we always need to have 4 characters, or yeah, 4 digits. So what pad is going to do, it's going to take an input n, and then it's just going to pad it to be a certain length. So yeah, again, right, pause the video, have a go, but right, I'm just going to jump in. So let's go function, we'll say pad. Right, this could be n, so it's going to take an integer, and let's also say maybe like target length, so this would be, for example, 4, so we want it to be 4 characters long. Right, and then so here you have to think, yeah, these are taking integers, but actually this is going to return a string, because it can return a string like 0, 4 zeros, for example. So right, let's go returns, this will be string. Again, end function, So here we have to think, well, how do we determine like how many zeros to add basically? And the way we can do that, there's a few ways we can do it really, but I think quite a simple way to do it is let's go declare. I know maybe let's go like num to add, or we'll just say let's say result, right? So this is going to be the result, and then basically, well, we need to convert this into a string, right? Because let's say we've got like 0. Well, 0 would be an integer, right? But again, this needs to be a string in order. Right. So what we can do, let's go result, and that's going to be right num to string, and right then we just go n like this. Now what we can do is maybe let's declare another variable, and you know again there's a few ways to do this, right? But let's say this can be the like the number of zeros to add basically. Let's say num zeros to add. Alright, let's say integer. So if we think about this, let's say here, well, if this is 0, right, so 0 is going to be 1 digit and the target length is 4, well, basically we can just do a subtraction. So we can do, right, 4, minus the length of this. Of course, right, not the length of this is an integer because that's invalid. So that's why we need to convert it to a string. So like, for example, if, let's say the string is, let's say we have 12. Well, then the target length is 4, right? The length of this is going to be 2. So that means the number of zeros to add is going to be 2. So what we can do, the num zeros to add, this is going to be the target length, and then minus the length of the result. And then basically we can just have a for loop, so let's go n. Again, let's start this at 1, right? And then, well, we want to loop until the number of zeros to add. Right, again, let's go next n, and then here we can just concatenate the result. Now, if you think, alright, so we can't actually go like, for example, we can't go result and then and 0, because what this will do is, well, let's look at an example. So let's say that result is 1. So if result starts at 1, well, then it's going to go 1, alright, then it's going to be, well, 1 and 0. So yeah, then you're going to have this. Then result is going to be 10, right, or the string 10. Then of course when we add another one, it's going to be 100, 1,000. So basically we want to do this first, right? So if we think how this will work, well, first is the result here is going to be 1, right? But then we're doing 0, concatenated with 1, so it's going to be like this. Right, then the result is going to be 0, 1. So of course, 0, 0, 1. So we just need to do it that way, and I think this should work. So let's go return, and we will go result, and let's just test a few of these. So let's go pad. Let's try 0. Right, and then let's also try. 5 should be the same. So let's just try maybe like 10. Let's try 100. And I guess 1,000. Although 1,000 shouldn't change. And we could also try what happens if we have more than 4. Technically this is invalid, so we don't really need to check. But let's just see. Right, okay, 2 arguments. So we say the target length should be 4. Okay, so 0, right, this is 10, this is 100, this is 1,000, and this one is fine. We could have some error message if we want, but I think for us, well, we're just going to assume that basically the error, we're going to assume that the input is always between 1 digit and 4 digits, because we're going to control these loops. Alright, so then let's say we want a pin number. So now we want to go onto this check pin function. So basically the user is going to have a pin number, like in their bank account, right there, kind of ATM machine. So if we just go declare and let's say pin. Now again, this can't really be an integer because let's say if their pin is 15. Well, again, we want this to be 0, 0, 15. And the problem is if we do, let's just see that. Right, let's comment this, and yeah, okay. Let's go output, and we'll just go output 0015. Right, let's see what happens. And yeah, you see, I mean, basically these zeros get cut off because, yeah, they're just unnecessary. Alright, so that's why this pin actually has to be a string. And I mean, let's give this just... Okay, I mean, actually, right, let's generate a random pin. Okay, so for this one we'll give it a known pin, right, just to test it. So let's say pin can be like 1, 2, 3, 4. Right, then let's make another function. So this can take in a pin as a parameter. So let's say it takes in 1, 2, 3, 4, and what it will check, you know, does that input pin equal the correct pin? Right, then it's just going to return a boolean, so true or false. Right, so let's go function. Let's go. Yeah, okay, check pin. I mean, I was going to say login, but I think check pin is fine. Right, so this can be kind of user entry. So yeah, this will be the pin that the user entered. Right, and then here it's just going to return a boolean. And yeah, let's go end function again. Right, so I mean here then actually we can do this just in one line, right? Literally just going, yeah, return pin is equal to user entry. Now some people find this a bit confusing, but basically this is just an expression. And you know, because we're using this equality operator, then this will just result either in true or false. Alright, so yeah, like for example, if pin is equal to user entry, then this whole thing is going to be true. Whereas I guess if the user entry is not equal to the pin, right, then it's going to be false. So yeah, then it's just going to, you know, return true or false. Right, the alternate way to do that is where you just have an if. So you say, yeah, if user entry is equal to pin, right, then you go return true. Right, then here we just go else, and then here it's just going to be return false. So I mean, these are going to be equivalent. I mean, some people find this a bit easier to kind of read, right? They find it easier to understand. Although, yeah, of course, it is a bit longer, and it is kind of a bit annoying having to type it out every time. But right, let's just try. So let's go output, check pin, and let's try 1, 2, 3, 4. So this should say true, or it should return true. And let's just say 1, 2, 3, 5. Yeah, okay. So then we get false. Right. So the final thing, what we want to do, well, we want to brute force the pin. So when we say brute force, well, this means try every single combination, right? So from let's say, you know, 0, 0, 0, 0 until you know, basically 9999. Yeah, well, 4 9s. Yeah, so brute force just means, well, try every combination. So I mean, yeah, I mean, okay, so for this, let's also make a, yeah, I guess we can also make a function, and then what this will do is this will return the result, or I guess it can return, let's say, an empty string if it didn't find the pin. Yeah. So right, let's say here then, and yeah, I mean, let's actually just delete these. So let's say function, and this can be brute force. So here we actually don't need any parameters. Like in some situations, maybe you'd want a parameter like maybe the length of the pin or something, because, well, I mean, a pin number is always going to be the same. Well, I mean, it's going to be the same, you know, if you have like the same bank, for example. But yeah, I know some pin numbers can be 6, right? Maybe some pin numbers might be 8 as well. And of course, if it's a password, well, a password, a user can choose like how long their password is. So yeah, maybe if it's a password, we would want kind of like a minimum number of characters to brute force, and then like a maximum number of characters to brute force. But of course, you know, a password is going to be much slower because, well, not only are there the numbers, but you've got to try all the letters, you know, the punctuation, the symbols. So yeah, this is why a pin is going to be quite easy to guess. Well, yeah, I mean, let's say easy to brute force. Right, so let's try here, and we want to say, yeah, so here we have no parameters. Let's go returns, and all right, let's say this is going to be a string, and all right, let's go end function, and basically we just want to loop. So we want to loop, let's say for for n is 0, and then we'll just go to 4 nines like this. Then let's go next n. All right, and then okay, let's declare it inside here. Okay, so let's say maybe current pin, and this can also be a string, and we'll say current pin. Well, this is why we have this pad, right? Because we say, well, we want to pad basically the for loop variable, and then to the length of 4. So right, let's go pad. That is going to be n, and then we want to say 4. And in fact, let's just output that again, just to check it's working. So right, I mean this is okay. I mean let's just go like return, and then what we'll do is, well, here we'll say return, or in fact, okay, let's just return an empty string. That's fine. All right, and then if we find it inside here, so here in a minute we'll check, and if we find it, well, here we would then return the actual correct pin. All right, so let's just go output brute force. Now the return value is just going to be empty, right? But basically we're just checking, well, does it output all the pins correctly? Okay, all right, so I thought that went into an infinite loop, but I guess it's just a little slow, since there's so many. So we've got 0, okay, that's correct. And then it seems, okay, right, so it seems that's correct, that's working. So what we then just want to do, then we just want to have if. So we can go if, and then that's going to be check pin. So this takes the user entry. So that's going to be this current pin that we generated. And I mean here we can go equals true like this. However, we actually don't need it, because well, this is saying right if true, which that's actually the same as saying this, because here this is, well, I mean let's imagine this is true. Then we check, well, true equals true. So right then the whole thing just becomes true. So I mean whether we have the whole thing is true, or whether just this is true, right, it's actually the same. But again, let's just be explicit, so let's actually say this. I think Cambridge do prefer it if you don't kind of like shorten the code basically. Right, and then so here, well, if it's true, then we can just return, and this will be the current pin. And then when it says, okay, let's say this, maybe pin is, and now the thing with this is that, well, if the pin is, if we don't guess the pin, then it is just going to return this. But in this case, we will get the pin because we're trying every single combination. Right, so let's just try that. Okay, and then we see, right, pin is 1 2 3 4. And let's also try this with a random pin. So let's say we want to get, let's say random, and this can go up until 999 like this. 9999. Right, however, remember this is going to be a double. So first we want to convert this to an integer. Right, however, again, this is still an integer, and then, well, we need to pad it like this. So what we then do is we can then say pad, and then just pad this to a length of 4, and then if we just run this, okay, so pin is 0655, pin is 4038, 4250. So this is working pretty well. Now obviously like a real bank, this is not going to work, right? A real bank, they're going to have methods to kind of prevent you doing this. So I mean, just have a think, right? Think how a bank could actually prevent you from brute forcing. Well, think what methods a bank would have, and then then we'll try to implement those. Okay, so one method is that a bank or even a phone, anything, they would only let you have a certain amount of login attempts, right? Then they would lock you out. So we can do something like this. Let's go declare, and then this can be, I don't know, like pin attempts, I guess. Right, this is going to be an integer. We'll just assign this to be 0. And then what we can do is in this check pin, let's say here, so we'll say the pin attempts is going to be, the pin attempts +1. So we're just incrementing them. And then what we'll say is, well, if the pin attempts is, I don't know, maybe like less than 5. Yeah, well, let's say less than or equal to 5, right? Because that will give them 5 attempts. Yeah, since we're kind of incrementing this here. Although actually, let's say that we only want to increment the pin attempts if they get it incorrect. Because yeah, we don't want them to get it correct, and then, you know, they kind of log out, then they get it correct again, log out, get it correct again. You know, because if they do that 5 times, right, then it also wouldn't let them log in. So yeah, let's say here, right, and then if we say, yeah, I mean, so we can say, right, if pin attempts is less than or equal to 5, you know, then we can do this, or we can switch the logic. So we could say if pin attempts is greater than 5. And then we can just go end if, and let's just say return false, right, and we'll also output an error message. So let's say, yeah, too many tries, and please wait, you know, like 60 minutes or something. And then of course, yeah, if this is a real website, you know, or yeah, a real, you know, bank phone website, you know, of course we could actually have code to actually check this. And I mean, yeah, well, you know, we can actually do this, although we won't, but we could do it just using the time function like this. Right, okay, anyway, let's try this. Okay, so, yeah, okay, so I guess that worked. So it gets to 6. Okay, so yeah, I guess it did 5, and then on the 6th time, yeah, the 6th time it outputs the current pin, then this check pin, right, then it's going to output this. Yeah, because I guess, right, if it's greater than 5. Yeah, so I think that works. Right, and then of course it's, yeah, just doing all of these. Alright, so yeah, let's see how long we've been going. Right, I think, yeah, it's been like well over an hour now. So, right, let's just try this one quickly. So we actually haven't looked at arrays yet. So I mean, yeah, this could be confusing, you know, if you've not done this in class. However, this is also like an important part of functions and procedures. So I mean, we'll also look at these again, right, in the array lesson. But the problem is, let's say, you know, well, I mean, some functions are going to require arrays. And then I guess likewise, right, some arrays are going to need functions. So it's not like I can teach functions first and then arrays. You know, they kind of both have to be at the same time. Because, you know, also things like this, right, if we're doing linear search bubble sort, well, these are also going to be, right, function, you know, procedure or function, right, depending on if we use ByVal or ByReference. But yeah, I mean, these are also going to, you know, need arrays as well. Alright, so let's just have a simple array, and let's go declare, I mean, let's just call it numbers or something. Yeah, it could be anything, or it could be, yeah, I mean, alright, so let's say volume, or maybe samples. So let's imagine that if this is a sound, so I mean, if you're familiar with, you know, sound sampling, I mean, let's say, you know, I don't know, say like what, 44.1 kilohertz. So, you know, like, well, 44,100 times per second, basically you're going to measure the amplitude, right, so the volume of sound. Now, let's imagine, you know, so this could be stored as an array. Now, let's imagine we want to increase the volume of the sound. Then, yeah, we can actually, you know, create a procedure that can do that. I mean, or we could do a function that can do it. So, let's see, so declare samples, this is going to be array. And I mean, we'll just do, I mean, let's say just 5, right, keep it quite small. And yeah, I mean, let's make it real. Although, yeah, I'm actually only going to do integer values, although, you know, if they're real samples, yeah, I guess it could be a real. Right, okay, so then let's just go samples. Now, I think, like I mentioned in another video, we can just do something like this, maybe, you know, 80, or yeah, 85, you know, 46. And yeah, of course, etc. And you know, as long as we have 5 values, and in fact, let's just do that. Let's go 10, yeah, maybe 20, and 30. Right, I mean this should work, and then let's go output samples like 1 for example. Yeah, okay, well actually let's just loop through them, just output them. So here then we want to go 1, then we go to the length of the array, then we just go output, and this will be samples and index n. And again, you know, right, if you've not done arrays, this might be confusing, but basically we're saying, well, this samples is going to store 5 different values. So in position 1 is going to be 85, right? Position 2, 46, yeah, so on. So here then we're just going to loop. So we loop from position 1 to the length of the array. Now the length of the array is 5, right? Because there's, well, 5 elements in the array. And then we're just going to output, well, samples n. So again, this n will be 1, right? Then, you know, the next loop is going to be 2, right? Then 3, 4, 5. So yeah, this should just output these numbers. Yeah, okay. So again, right, we can do it like this. I mean, let's say if we have like 6, right, then it should give us an error. Yeah, okay, well, sample 6 is undefined because, well, basically here we only have 5. Now, again, you know, I think before I did have a better error message. Yeah, so I will actually improve this at some point. And yeah, as you probably saw, like, let me just plug in my laptop. Right. Yeah, so, well, like I was saying, right, we could do it like this. However, Cambridge, they actually prefer us to do it more explicitly. So we say samples 1, I don't know, I mean, let's just say 50. Right, and then let's just go like 60, 70, 80. And then, yeah, so here we need to change the index values. So we're saying, yeah, position 2 is 60, right, position 3 is 70. Or I guess, yeah, index 3, index 4, right, index 5. Right, then if we do that, and yeah, we can see here. So what we want to do basically is, well, we want a procedure, let's call it maybe increase volume. Or in fact, actually, let's do it with a function first. So if we go function, yeah, maybe let's say change volume, because, right, this could go up or down. Then we'll just say n. Yeah, okay, n. Right, this can then be the amount. Right, in fact, well, let's call it amount, right, that makes sense. And okay, let's actually say this can be a real, because we could say, you know, reduce by like 0.5 decibels. Right, now if it's a function, now because, well, again, a function has to return a value. So here we'd actually say, well, return, and then this is going to be, yeah, array of integer, like this. In fact, no, sorry, right, array of real. And the thing to note is that, well, here we actually need the dimensions of the array. So we're saying it starts at, you know, starts at index 1 and then ends at index 5. Now here we don't need the dimensions of the array. And the reason for that is that, well, this should work for any size array. So it should work if we have, let's say, you know, 3 elements in the array. Yeah, or it should work if we have, you know, 3 million or, yeah, 30 million. Yeah, I mean that's the whole point, right? You know, it should be flexible, basically. Right, okay, so yes, what we want to do then, I'm just going to copy this because it's just the same. And actually, let's say, I mean, so yeah, we could do it here where, you know, we're directly kind of updating the global variable. And if you don't know, well, a global variable, that's one in the sort of top level scope. So that means it's not inside a function, it's not inside a procedure. Yeah, I guess also, you know, not inside any like if statement or for loop. So because it's global, well, anyone can access this. Now, if, for example, we go here, like declare, I don't know, like x, and that could be integer. Well, because x is, you know, declared inside this function, then x can only be used inside this function. Like if we tried to, you know, output x, yeah, this would give us an error message, saying like a is not found. Because again, yeah, x is only, you know, declared to be used inside this function. So yeah, you know, we could update the samples like this, and actually for, yeah, for like IG and A level, this is actually what they want you to do. I suppose just because it's simple, right? So if they've got an array, Like I've never seen them where they've had an array as a parameter. Or yeah, like maybe they do sometimes, although it's pretty rare. I think usually they just say arrays are going to be global, just to keep it, more simple. Right, but I mean here, well, let's look at how we can actually, make it kind of, make it a parameter. So I mean we could just call it samples again, but the problem is because this is called samples, maybe it's a bit confusing. So I mean, let's call it maybe, I don't know, like sample parameter basically. Right, so this is going to be an array, also it's going to be of real, and then for the same reason we also don't need to declare the dimensions, because this should work for any sample, it should work for any dimension array. Right, okay, and let's just delete this declare x. So here then we want to loop these samples param, and right here this is also these samples param. Samples parameter, and then let's just say, okay. At the moment, let's just return this sample param. Although, we shouldn't really do this, but I mean, I'm just going to do this because, well, otherwise it will give us an error message saying we're not returning anything. So if we just run this, let's go output change volume. This will take these samples. And then, right, it's going to have an amount, so let's say 5. So we just want to increase the decibels by 5. Alright, now of course here it's actually not increasing them. We're going to check it's still working. So yeah, I mean, it should just output this basically. Let's just delete that and check it works. Unexpected token return. Okay, so yeah, here I guess I just mistyped it. So yeah, when we say the data type that it returns, well then we use returns. But when we actually return a specific value, right, that's when we say, well, return, so with no s. Okay, and then, alright, so here it's just saying can't convert array samples to string. That's because I had this output. So if we just delete that output, and then you see it's going to successfully work. So what we want to do then, well, we just want to update them by 5. So let's go, like this, and let's go assign. Then we'll just go sample param, that's going to be n, and then plus amount. And now actually let's just, let's make a procedure, and this procedure will be to output the array. So right, let's go output array. Right, and again, let's call this like ARR, because, well, this can be anything. And let's say here this is also going to be an array of real. And again, of course, we don't need the dimensions, right? And well, since it's a procedure, right, we also don't need the return. Returns. Right, end procedure. And then, well, let's just do it again. So we just want to go for n. And then so we're going to start at 1, right, then we go to the length of the array. This array parameter, which, I mean, in this instance, well, this array parameter, they're going to be these samples. Although, of course, we could have, say, samples 1 and then samples 2, which would be different arrays, different sizes. I guess different dimensions. Right, then let's go output. This is going to be array and index n. Then we just go next n. Now, if we try that, what we want to do, so we want to assign this. So we say samples is, so we just do this, right? So we have samples, then we assign it the result of this. Because this result, well, it should take this array, kind of 1 by 1, right? Is then going to add 5 to each one. Then it's going to return the whole array. Then we can assign this new array, right, to the samples. And then let's just go output array, and then this is going to be samples, and let's also do it here, right? And I guess since this is a procedure, we need to call it. Right, let's also go here, call, let's say output array, and let's also go samples. And what we can do is let's just add, some kind of hyphens like this just to separate them. So hopefully. Okay. So we see here then, right, this has successfully worked, because, well, here we're just outputting the original array, yeah, then we're going to change the volume by 5. And if we look, well, samples, that's going to be, right, this array here. Then what we do, so yeah, well, we pass this as a parameter. Right, of course, well, then we just loop through this array, and then, yeah, we take this parameter, we just add 5 to it. Then we just return this, parameter array. Yeah, however, this is not really good, and well, the reason it's not very good is because, well, here we're actually creating a copy. So any time we're using ByValue, and I guess the thing to note is that, well, ByValue is the default. So anytime we use ByValue, that will create a copy of all of these parameters. This is maybe a little bit, maybe a little bit above the scope of this video, but basically, when you call a functional procedure, then there's going to be 3 things that are copied, into the stack, onto the stack. So basically, the stack is going to be part of the computer's RAM. So anytime you call a functional procedure, then it's going to be, one is going to be the parameters. So the parameters are copied, right? Also the local variables are copied, and then also the return address. So I mean, yeah, like if this doesn't really make sense, well, yeah, like probably don't worry about that, because that's not really the purpose of this video. But if you think, right, let's say the parameters, right, let's imagine this is a video. Now a video can easily be, like 1 gigabyte, 10 gigabytes. I mean, if it's uncompressed, it will literally be terabytes. So if you have like a 1 terabyte video, but let's say you only have, 16 gigabytes of RAM, or yeah, maybe 8 gigabytes of RAM, well, you're going to get a problem, because, I guess maybe GB or gigabytes. But anyway, you're not going to be able to copy that onto the stack, because, well, the stack is not going to be big enough. And well, to be honest, right, the stack is a lot smaller than 8 gigabytes. Probably just, a couple of megabytes, maybe, like 1 megabyte or 16 megabytes, right? It's going to be quite small. Not only would you run out of memory, which, for example, maybe you're familiar with the Stack Overflow error, right? I mean, also, yeah, the name of the programming website, but the Stack Overflow error is literally, well, when there's not enough memory on the stack, or when you've like consumed or used all of the memory on the stack. But I mean, the other problem is, well, it's just going to be slow. Like if you're having to copy like a 1 gigabyte video, sort of back and forward, on and off of the stack, right? I mean, that's going to be really slow. So instead, a better way to do that is going to be using ByRef. So yeah, let's just look how we can do that. So by reference, well, this will let us kind of update the original, the original object. So in this case, the original array directly. Right, so here we actually won't need to return anything. So because of that, well, we can say this is going to be a procedure. Then let's say end procedure. Then what we'll do is we'll say this is going to be ByRef. So yeah, ByRef means, well, yeah, again, it's going to pass the actual data object, right? It won't create a copy. So this means that, right, when we change this, this will actually directly update these values. And I would say if you want to look more about, ByValue, ByRef, if we just go down here, yeah, again, we've got 2 examples, right? One simple, and then, yeah, we've also got arrays here as well. So, yeah, just have a look at these in your own time. Right, and then, yeah, because it's a procedure, right, we also don't need to return. And then because we're not returning, well, yeah, we then don't need to assign it back to the samples. So I think, yeah, if I've not made any mistakes, then I think this should work. So let's just, let's just delete this to make sure it runs again. And okay, yeah, all right. So what this is saying is that, well, because this one is ByRef, then basically it's going to consider, this one to also be ByRef. Because, yeah, if we only use one key, if we only use one sort of parameter passing keyword, then it's going to assume that all of them are the same. Now, I think in the pseudocode, in the pseudocode guide, it says you shouldn't actually use ByValue like this. or sorry, well, you shouldn't use ByRef and ByValue in the same kind of in the same procedure, right? However, I noticed in the mark schemes they actually have done this in the exams, so yeah, I'm not, you know, I guess it's fine. Right, and then yeah, so if we just run that, and then yeah, so here now we just get no errors. Right, so what this is saying basically is, well, this sample params, because we're using by reference, then that actually means, well, we're not creating a copy of, you know, this parameter and then yeah, like modifying the copy. We're actually you know, directly kind of editing this, or yeah, we're directly, you know, accessing, modifying like the original data. I mean, again, let's just look at that quickly. So we'll just go here, right, then we'll finish. So right, yeah, let me search it by ref. So for example here, right, so let's say we've got N1, N2, and again, right, this is not really the purpose of the video, but since we're talking about it now, right, let's have a look. So if we say, right, N1 is going to be 111, now we call this, right, by value 1, well, with this, you know, N1. So if we look, right, by value 1, well, here we set it to 222. And I guess if we just output this, right, we can then see, right, this will say 222. But the thing is, right, this parameter, because it's by value, well, yeah, because by value is the default. So I mean, basically, it's like this, right? If we don't have either ByVal or ByRef, then it's going to be ByVal or ByValue by default. Yeah, so because it's by value, well, it's going to update in this function, or well, sorry, in this procedure. But then yeah, it's not going to modify the original, right? And then the original was this one. So yeah, well, I'm just going to comment out some of these because it's going to get a bit complex. Yeah, I mean, probably here. Okay, actually, yeah, here. Right, so if we just run this, now, yeah, you see it says 222, so 222, well, we're assigning X, we're saying, you know, we're just outputting here. Right, but then it's just going to output, yeah, 111, because, well, basically this, yeah, this N1 has not been updated, right? Because what it's done is, well, it's created a copy of this N1, which we've actually called this, like, X parameter. And then, yeah, then we're just assigning to this copy, so it's not the original data. Right, but then if, for example, yeah, let's try this one by ref 1. And yeah, here actually let's comment out these. So here we say, well, again, let's say N2 this time. This is going to be 111. Right, and then let's see what we're doing. And yeah, let's just uncomment this. So, I mean, here they should both be 111. Okay, right, so here we're saying by ref X and Y. So then X is going to be 222. Now, if we look, right, X is going to be this N1. So now N1 should be 222. And yeah, N3, well, if we look, right, that should be this 333. Yeah, so I mean, let's just run that. And yeah, I mean, here we can see, all right, so, I mean, again, the key thing is, if we're using ByVal, so like this one, then, you know, ByValue is going to create a copy of this parameter, then it's going to update the copy, whereas if we're using ByRef, well, it's going to use the original, yeah, the original object, right, the original variable, which in this case, well, the original variables are going to be N1 and N2, all right, and then of course it is going to directly update those original variables. And the benefit of that, again, if we go back to, say, the video encoding example, now if we've got a video and we have, you know, let's say a procedure in order to convert that video from MP4 to like AVI, for example, so just, yeah, converting video formats or, yeah, changing resolution or something. Now, if we're creating a copy, well, again, we have to copy the entire video, you know, sort of onto the stack. Whereas if we're using by reference, well, we don't have to create a copy. We can just directly update the original data. So, of course, right, this is going to be a lot faster. Yeah, and, you know, we're not going to get errors like, you know, out of memory or stack overflow. Right, anyway, guys, so I think, I mean, that video went on kind of a lot longer than I expected, you know, especially talking about this stuff at the end. Yeah, hopefully that makes sense. Now, if it doesn't, right, again, just, right, leave a comment. I mean, probably also ask your teacher, you know, like assuming that people actually like aren't doing Cambridge privately. Yeah, I mean, if you sort of have normal classes, right, just ask your teacher about this stuff. But again, right, so hopefully that was kind of useful, and hope to see you in the next video.